Now, after simplifying basic radicals worksheet, which is what we just did, and you guys proved to me that you've completely understood Friday's assignment, now we're going to go to the next concept of radicals. And again, this may or may not have been a topic of review from Algebra 1, okay? But it is something that our textbook assumes that you guys know, when in actuality you probably did not master in Algebra 1 and have forgotten how to do it. So therefore, I need to make sure that you're aware of it. Because the answers in the textbook or on the worksheets are not going to match without rationalizing them to get the correct answers. You with me? So, rationalizing radical expressions. No radicals can be in the denominator of a fraction. It's not possible. Mathematicians do not like radicals in a denominator. We just don't. Okay? So what we do is we call it rationalizing. When you rationalize the denominator, this is the process used to eliminate a radical from the denominator by multiplication. You with me? By multiplication. Now, what I did, just like on Friday's assignment, I did half of the problems for you. The same thing is going to happen on tonight's assignment. I did make a worksheet for you, not because I meant to, but because I fell into an old habit at the copier machine, and I thought I was supposed to be copying whenever I was supposed to be scanning. However, I did put this in your Google Drive as well, so it is there, and you also have a paper copy of it. You're welcome. It should be a little easier for you to do your homework assignment tonight. Okay, so here we go. Number 2. Number 2 is the square root of 1 over 13. Now, when we do a problem like this, what we want to do is we want to divorce the numerator and the denominator. Currently, this is one fraction. Y'all with me? And we're going to separate into two fractions by writing this as the square root of 1 over the square root of 13. Do we get that? Yes or no? Now, what is the square root of 1? 1. This comes out as a 1 to give me 1 over the square root of 13. Can I do anything with the square root of 13? No. Okay, we're not done with that problem, but here's what you need to understand. If I have the square root of 25, that's the same thing as 5 squared, which is the same thing as 5 times 5. So I had to have a pair of 5s in there to pull it out of the radical, which gives me just 5. Do we all understand that, yes or no? Make sense? Okay. If I had the cube root of 125, that's going to be what? 25 times 5. 5 quarters makes $1.25, right? Well, that's going to be the same thing as 5 squared times 5, which is how many 5s inside there? 3. So in order to pull one 5 on the outside of a cube root, how many 5s do I have to have on the inside? 3. So this gives me 5 as my answer. Does that make sense? What if I had the 5th root? How many of one item would I have to have inside there then? 5. If I had the 7th root? If I had the 10th root? Do we all understand where I'm going with this? Okay, glad we understand that. If we come back here and we look at our problem, how many 13s do I currently have underneath there? 1. In order for me to pull 1 on the outside, how many total do I have to have inside? 2. So how many more do I need if I currently have 1 inside? I need 1 more. So what we're going to do is we're going to multiply by a value of 1. 1 takes on infinitely many different shapes, sizes, or values. Agree? 1 can be equivalent to 5 divided by 5. Would you all agree? Yes? It could be x divided by x. Yes? It could be the square root of 2 over the square root of 2. Is that legal? Yes. So what we're going to do is we're going to utilize this last concept here, and we're going to apply that to every one of the problems that we're going to be doing. Does that make sense? You said that in order to have a 13 on the outside, you have to have 2 on the inside of the square root. Yes? And you said we needed 1 more. So what we're going to do is we're going to multiply by what we need. I need 1 more square roots of 13 down there. So we're going to multiply by the square root of 13 over the square root of 13. We're going to marry the tops. That gives me the square root of 13. And on the bottom, how many 13s do I have? And what happens to that power and that root? They cancel out, right? So that comes out as a lovely 13 to give me the square root of 13 over 13. Do we understand that? Yes or no? It's exactly what I did here. 5 squared is 5 times 5, which just is 5. Okay? Number 16. Number 16. It's exactly the same concept. Okay? And I'm going to show you this problem 2 different ways because I think your brains think in 2 different manners. Okay? Now, 1 over the square root of 8. Can I simplify the square root of 8 from Friday's assignment? Think like Friday's assignment. I can. Are there perfect square factors of 8? What are they? This is going to be 1 over the square root of 4 times 2. And what is the square root of 4? So I actually have 1 over 2 square roots of 2. Would you all agree with me? Yes? Okay, well that's all wonderful. But what do I have in the denominator that I cannot have? I have this lovely little square root of 2 here. And guess what, folks? I can't have that in the denominator. The 2 on the outside is perfectly fine there, but the 2 on the inside is not perfectly fine. So how many do I have currently underneath that radical? 1. How many more do I need? 1 more. So I'm going to multiply by the value of what I need. I need 1 more square roots of 2, and I'm going to multiply that by the square root of 2 over the square root of 2. Agree? So now what do? I marry the tops, and then I marry the bottoms. What's the square root of 2 times the square root of 2? Square root of 4, okay. And what is the square root of 4? So I'm going to have the square root of 2 over 2 times 2 is 4. Now remember whenever I said I was going to do this problem 2 different ways? Okay. How many 8s do I have in that denominator currently? 1. How many more do I need? 1. So could I multiply by the square root of 8 over the square root of 8 right away? I could. And that's going to give me the square root of 8 over the square root of 64. Well, what is the square root of 64? 8. So this gives me the square root of 8 over 8. But can I simplify the square root of 8? What is that? That's going to be the square root of 4 times 2 all over 8. Well, what is the square root of 4? So I actually have 2 square roots of 2 over 8. Well, what happens to the 2 and the 8? They reduce down to what? That goes away, and this becomes a 4 to give you the square root of 2 over 4. Same exact problem, but we rationalized first and simplified second. Whereas the first way I did it, I simplified first and then rationalized. Do we see that? Do I care which way your brain does it? Nope, just get it done. Y'all with me? Okay, excellent. Moving right along, number 20. Number 20. Okay, talk to me. What do I do? Right now it's written as 1 fraction, isn't it? Before you can rationalize, what should you always do? Make it 2. So I need to separate this and make this the square root of 3 over the square root of y. Now, how many y's are currently in the denominator? 1. How many do I need? Why do I need 2? Because it's the square root, right? If it was the cube root, I would need, if it was the 5th root, I would need 5. We all good on that. So I currently have 1 y in the denominator, so I need to multiply this by another what? Square root of y over the square root of y. So now, what do I do at the tops? And what does that give me? The square root of 3y all over the square root of y squared. Yes? What is the square root of y squared? Do we all understand why that becomes y? Because the power is 2, the root is 2, and 2 divided by 2 is what? 1. Do we understand that? So this gives me the square root of 3y over y. Yes? Okay, again. 18. 18. Same concept. So what should I do? Make them 2. Okay. Seven ab cubed all over the square root of c. Okay, that's fine. Please make sure you say it's the square root of c, right? Now what? Okay. 7a b cubed c all over the square root of c. Am I done? This should be squared. Very good. What is the square root of c squared? Okay, so this is going to be the square root of 7ab cubed c all over c. Am I done now? Why? 3 what? There's 3 b's. When your exponent is larger than your root, you know you're not done. Does everybody understand that? When your exponent on a number or variable is larger than the root that you're taking, you're not done. Okay? Which tells me that I need to break this up. This is going to become the square root of 7a b squared times b times c all over c. Why did I split that up as b squared times b? Because b squared and the square root of that can come out as a b. So this comes out as a b, and I'm going to be left with b square root of 7abc all over c. Does that make sense? Yes? Excellent. 27. 27. That's not the right number then. It's 22. I can't even read my own handwriting because I got crazy there. 22. Why make them 2? Okay, good. So this is the square root of 1 over the square root of x cubed. What is the square root of 1? 1. Oopsie, sorry. 1 over the square root of x cubed. Sarah. Oh, not Sarah. Ashley, sorry. I absolutely can, but am I still going to have to rationalize it? I am. So could I do like I did on the problem 16, I think, where I showed you 2 different ways? Could I rationalize this first and then simplify it second? Could I do that? I absolutely can. 3 is not divisible by 2, but is there a number larger than 3 that is divisible by 2? 4, 6, 8. We want the one closest to 3. So we want to use that 4. So I need to have 4 x's inside there. So how many do I need to multiply by? Just by one of them. So if I multiply this thing by the square root of x over the square root of x, this gives me the square root of x all over the square root of x to the 4th. Do we see that? Because that's how many x's I now have underneath there in the denominator. Now what is the square root of x to the 4th? Take the power, which is 4, and divide it by the root, which is 2, to give you what? X squared. So this comes out as x squared to give me the square root of x all over x squared. Makes it a lot easier to rationalize this first rather than simplifying, then rationalizing. Does that make sense? We all good? 24. 24. Look at that very closely. Tell me what you think we should do. I'm sorry? They both have a 5 in them, so what are you proposing we do? What has been our first step every time? To put them into 2. It's already in 2, but you're saying that they both have a 5 in them, so what could I do? Put it back together and simplify it, right? That's legal. If I can tear it apart, I can put it back together. So this is the square root of 45d over 5e. What happens to the 45 divided by 5? What's it reduced down to? 9d over e. Now, can I take the square root of each one? Sure. Do we see that? Now, I know the top needs simplified. But not only does the top need simplified, what do I need to do to the bottom? I need to rationalize it, right? There's currently only one e in the denominator. How many e's do I need? 2. Why do I need 2? Because I'm taking the square root, okay? I need to multiply by one more. So if I multiply by the square root of e over the square root of e, what is the square root of 9? That comes out as a 3, so I'm left with 3 square roots of d, e, all over what? The square root of e squared. And what does that come out as? An e to give me 3 square roots of d, e, all over e. Make sense? Last one. Yep, sorry. You're welcome. Okay, 26 is the last one I'm going to talk about. What are your thoughts? What would be the point? 72 is divisible by 5? It's not. So will it help us to marry them back together? No. So if it won't help us, the next question is should I go ahead and just rationalize it and simplify it last? I probably would. So how many different bases do I have under the denominator? What's one base? Oopsie. Oopsie. That's one base. Would you agree? Well, what's that 5 doing? It's also a base. I can't ignore it. It's different. So how many 5s do I currently have in there? How many do I need? 2. I currently have 1, so how many more do I need to multiply by? I need to multiply by the square root of 5 over the square root of 5. Would you agree? Okay, now what about my y's? How many y's do I currently have in there? 3. Is 3 divisible by 2? I need how many more? I need one more to give me a total of how many then? 4. So I'm going to turn this 5 into 5y on the top and the bottom. Do we all see that, yes or no? So now let's marry the tops. That's going to be 72 times 5x squared y all over 5 squared times y to the 4th. Yes? Take 72 and divide it by 2, folks. $36. Is 36 a perfect square? Sure is. So this is going to give me 36 times 2 times 5x squared y all over 5 squared y to the 4th. Now what is the square root of 36? Can I do anything with the 2? Can I take the square root of 2? Can I take the square root of 5? Can I take the square root of x squared? So that leaves me with I can't do anything with the y. That leaves me with 6x square root of what? 2 times 5 times y gives me what? 10y. All over, what's the square root of 5 squared? What's the square root of y to the 4th? Y squared, all over 5y squared. Done. Now, you guys owe me all the odds except for problem 3 and 15. 3 and 15 you can eliminate. You're welcome. Those are kind of nasty numbers. I don't want you focused on a nasty number. I want you focused on the process. We all good? Okay, tomorrow. Well, wait, before I do that, we're all good with this? We understand it? Make sure you show me your work. No questions? Okay.